This is Geometry 11.1, Angle Measures in Polygons. So we're going to take a look here at different angle measures, interior angles of a polygon, based on how many sides that polygon has. So if we take a look at this table that I've created, first column is polygons, number of sides, number of triangles, then sum of measures of interior angles. And so filled in the first one already. We know that triangle has 3 sides. How many triangles can you make out of a triangle? Well, just one. And the sum of the measures of the interior angles, I'm going to take how many triangles I can have times 180, and that's going to give me the sum of the interior angles, and that would be 180, because we know that no matter the triangle, scalene, isosceles, obtuse, acute, it always, all 3 angles on the inside are going to add up to be 180. Next, let's think of a quadrilateral, so a 4-sided figure. Here I have a rectangle. How many sides? Well, we know that it has 4 sides. How many triangles? And so what I'm going to do here is I am going to just cut this guy in half a little bit. And I've created 2 separate triangles. And so we know that with those 2 triangles, we already knew what the answer was in the next one. The sum of the measures of interior angles would be 360. We knew that, but 2 times 180, so 2 times that number of triangles. Again, the number of triangles, 2 times 180, so I get 180 as the sum of the measures of the interior angles. 360, sorry, for a quadrilateral, 180 for a triangle. This pattern that we're going to see emerge continues for all shapes, all polygons. So for a pentagon, how many sides? Here we have one down here. We have 1, 2, 3, 4, and 5. 5 sides for a pentagon. How many triangles can I have? Well, let's try to break this down a little bit. I'm going to draw one. Yeah, a little too low. Draw one right here. And one right here. And so we can break this pentagon into 3 triangles, and we can think about this. Okay, well, this triangle up here is going to be 180 degrees, this one 180 degrees, and this one 180 degrees. And why this works is because this is all referring to the vertices of my triangle, so, or in this case, my pentagon. And so all of these 180 degrees added together are going to give me the sum of the interior angles of a pentagon. And so the triangles that I figured out were 3. So I'm going to take 3 times 180 degrees. So that's going to be 540 degrees is my total. 540 degrees is the sum of all of the measures of the interior angles. Last one that we're going to draw is a hexagon. We have 6 sides. We know that for a hexagon. 1, 2, 3, 4, 5, and 6. 6 sides for a hexagon. How many triangles? This time I'll just try to freehand it a little bit. So there's one. There's another. And if I cut that one, cut that one there. So I would have 4 triangles. 4 triangles that I can come out of this hexagon. Again, each of these triangles is going from just drawing one line from one vertex to another. That's how we're creating these triangles. One vertex to another. And so this time I did 4. And so that's going to be 4 times 180 degrees. And so every single hexagon, doesn't matter if it is a regular hexagon or an irregular. So again, a regular hexagon means that all of the angles and all of the sides are congruent. All the sides are congruent, all the angles would be the same. they're all congruent as well. And so we start to see if there's a pattern here. So what I want to talk about with this n-gon down here is it has an n number of sides. In a way, you can say that that's any number of sides, no matter what, some number of sides. How many triangles? And so let's take a look here at the how it goes from sides to triangles. We'll see that 3 to 1 is subtracting 2, 4 to 2 is subtracting 2, 5 to 3 subtracting 2, 6 to 4 is subtracting 2. And so no matter how many sides I have, I can figure out how many triangles I could create by taking the number of sides minus 2. And so finally, I can come up with my own idea here. So n minus 2, kind of our own formula, n minus 2 times 180 will give me whatever happens to be the sum of the measure of the interior angles. And so this will work on any number of sides. So let's say we're told or asked on an example, what is the sum of the measure of interior angles of a shape that has 12 sides? 12 sides. And so what we'll want to do is take n minus 2 times 180. Well, n is 12 in this case. So 12 minus 2, 10 times 180. And so the total sum of the interior angles would be 1,800 degrees. All of them combined. Okay. Now, that works for any polygon. So no matter the number of sides, we can plug in n to figure it out. Another question we might be asked, however, is what is the measure of each interior angle of this regular polygon? So let's think about that one for a second. If I'm talking about this rectangle, what's the measure of each interior angle? Now, I guess this wouldn't be a regular polygon. I would need a square. Square would be a regular polygon, so we'll use the square. What is the measure of each interior angle of this regular polygon? Well, since this is a square, we already know it, but all of these, since it's a regular polygon, have to be identical, okay? And so each of them would be 90 degrees. But how could we figure that out if we didn't know if it was a different shape, such as an octagon or a hexagon? And so what did we do if we think about the 360 right here that has to do with quadrilaterals? What did I do with that to get to 90? And so what I did was I took the sum of the measures of the interior angles, sum of interior angles, divided by what number? Well, 360 divided by 4, and so in this case, I took the number of sides. So sum of interior angles divided by the number of sides. So again, for this square, 360 divided by 4 gave me 90 degrees for each. But let's take this and kind of change it so that it uses n instead. So the sum of interior angles, well, earlier I did this as n minus 2 times 180 degrees. And now I'm dividing by the number of sides. Well, how many sides does an n-gon have? It has n. So this is a way that we can figure out the interior angles, well, each interior angle of a regular polygon. So every single polygon, let's again say, I'm given a regular polygon with 18 sides. And if it has 18 sides, it's a regular polygon, so all 18 sides are identical. What's the measure of each of those sides? So I'll plug 18 in for n. So 18 minus 2 times 180 divided by 18. 18 minus 2, 16 times 180 divided by 18. So I have 2,880 degrees divided by 18. And so this is actually giving me two pieces of information. The 2,880 degrees is the total interior sum of all the angles of an 18-sided figure. If it's a regular polygon, I'm going to divide that number by 18 and find that each angle of an 18-sided figure is 160 degrees. 160 degrees. Your homework is page 665. For 6 through 13 and 17 through 19. If you have any questions, please email me. You can send me a picture of the question. You can send me what question it is, so I can help you figure that out. Thanks.